Okay, so we're working with this. The x equals b to the y, b being whatever base you have set that exponential equation to use. They've already replaced your x with your y. So the notation for this looks like that. B is written as a subscript. Your base is written like that. You need to make sure your subscript is small and not the same size as x. It should look like a subscript. So it's read as y equals log base b of x. So the function that we work with b is not equal to 1. Because if an exponential equation has a base of 1, that's not an exponential equation. The base has to be greater than 1 or between 0 and 1. You can't have a base or a logarithm that is 1. Okay? So the first things we're going to do is look at rewriting our logarithms as exponential equations and our exponential equations as logarithms. Just being able to transfer them back and forth. That's the big part of today, because oftentimes you are solving these equations, and in order to solve, you have to get it out of exponential into a logarithm or the other way in order to continue solving. All right. For an exponential equation, so we have our base. So we've got our base right here. The base is always going to be the base, whether it's as an exponential or as a logarithm. So the first thing I'm going to do is I'm going to pull 243 out. Equals the base 3 to the 5. Okay, so keep in mind, this is considered our x. Just kidding. So there's our base. Here's our y. I meant to put that as 5 instead of, there you go. It should make mathematical sense. 3 to the 5th power is 243. If you write that any other way, it's not going to be a true statement. Because 243 to the 3rd power is not 5. And the 3 to the 243rd power, yeah, still not 5. 5 to either of those. So it will be a true statement if you write it correctly. Otherwise, no. So again, here's our base. Logarithms always equal the exponent. All right? So, 225 equals 5 squared. 15 squared. Wow. And that's true. 15 squared is 225. So how would we start writing number 2? Okay. 1 over 27 equals, what's our base? 3 to the negative 3. So number 3, how do we start? 2 equals 4 to the 5/2. Again, easy to check in your calculator to see if you have that written correctly. Okay. Okay, so here's what we kind of started doing with the graphs. Is we have the equation b to the y equals x. That's what we started working with. Therefore, y equals log base b of x. So that means 7 is our y and 128 is our x. What goes first on number 4? Okay. Log base 2 of
128.
Yep, equals 7. You can write it either way. You could also write it 7 equals log base 2 of 128. Okay. It's about 5. Log base. Yep. Of
16.
Okay, so some things to check on your logarithm. That it equals the exponent. And that this is still your base. The base from the exponential equation should still be the base in your logarithm. Okay? Number 6. What do we got? Log base 7 of
1/34.
Yep. Sometimes when it gets fractions or other things, it's easier just to put that in parentheses. Again, but still making sure that your base is a base. Okay. All right. So the other part of this is evaluating a logarithm. All of your logarithms, regardless of the base, have a value. Sometimes they come out to be nice integers or fractions. Other times they're decimals that you have to round. So what we're working with today is going to come out to be an integer or a fraction. First thing, turn it into so that it equals x. Well, to find that value of x, I could rewrite that as an exponential equation. So I could say 16 equals 8 to the x. How can I figure out that value? We can't divide it by 8 because it's not 8x, it's 8 to the x. What do we have that we just worked on a homework quiz for this?
Make up the same base.
Make them the same base. So 16 and 8 can come down to what base? 2. Yes. So 16 is 2 to the 4th. 8 is 2 to the 3rd. Now that they're the same base, I can drop the base. 4 equals 3x. So x equals 4/3 when I divide both sides by 3. So log base 8 of 16 is 4/3. That's its value. So if we look at number 7. First thing to figure out that value for x, rewrite it as a exponential equation. 64 equals 4 to the x. What base do I want to use here? We can use 2. So 64 is 2 to the 6th. 4 is 2 squared. Drop the base. 6 equals 2x. Divide both sides by 2. We get 3. See what you can do with 8 and 9. All right. Go 64 equals 2 to the x. We know 64 is 2 to the 6th. Drop the bases. 6 equals x. The last one on this section, 100,000 equals 100 to the x. Using a base of 10 on this, 10 to the 5th equals 10 squared. So it's now 2x. Drop our base. 5 equals 2x. Divide both sides by 2. And 5 halves or 2.5. Either one of those work. Questions on these 3? All right, let's take a look at our last 3, and then we'll go back to our graphs. So 5 equals 25 to the x. What base are we going to use? 5. So 5 to the 1 equals 5 squared. Drop our base. 1 equals 2x. So x. So log base 25 of 5 is 1/2. We'll finish up the last 2 All right, so 11. Again, we're going to let it equal x. I'm going to bring it out. 1 over 128 equals 2 to the x. So 128 is 2 to the 7th. Keeping in mind, you can't have 1/2 versus 2 as your bases. So I need to make that as 2 to the -7 equals 2 to the x. When we drop our bases, x is -7. So there's our exponential equation. We want a base of 10. So what base of 10 would that be? Yes. So keeping in mind that is 1 over, because that's 100,000. Okay. So keeping in mind what that really is. So dropping your bases, x is -5. Okay. The next part is graphing it. Okay, graphing logarithmic equations because we can find its inverse from an exponential equation. So, looking at these, you got all this information, but keeping in mind your domain and range are going to switch. So let's go back to our Desmos activity. And go to slide 10. That's what we're open to next. You've already got the base. So you've got the parent function for this. So now the question becomes, if it's 2 to the x plus 2, where would that extra plus 2 go in your logarithmic equation to be the inverse of the one that's there? So somewhere in this logarithmic equation, you're going to have plus 2 minus 2, somewhere. Whether it's inside the parentheses or outside the parentheses. So do some testing, see where it might go. You should already have the parent function. We need to make the adjustments. I'm telling you to use Desmos. Don't try to graph these on your own. Okay? So if you haven't, go on ahead and make sure you have the Desmos graphing calculator up on your Chromebook. So our first one is the exponential equation. Y equals 2 to the x. That's going to approach 0. And it's going to look something like that. Again, as we are going, the one thing you should make sure you have on your on Desmos itself is have this equation, y equals x. That'll give you a really good idea if you got the correct thing. Now, I don't want mine purple. I want it to be the black dashed line like before. So I'm going to go to my settings. And I'm going to go here. I'm going to change the color. And I'm going to change it to dashed. Okay, so your settings allows you to change the colors of these equations. Now, I'm going to type the exponential equation. Again, I don't want it that color. So domain of exponential equations, as we remember from the day one of this, all real numbers. The range, this one is approaching 0. So what I would write for that is the domain, all real numbers, the range, approaching 0. Number 14 is the logarithm for this. So y equals 2 to the x. So what's the logarithm for that? Y equals log base 2 of x. So now I'm going to graph that in Desmos. And there we have it. So keeping that y equals x line on there allows you to see if you truly do have those inverses correct. So you see if you have those graphs in the correct spot. Okay? Now, coming up with our domain and range, and you're just going to copy the sketch from Desmos onto here. So I have this. Then I'm going to go and there's my graph of the logarithm. If my domain is this, all real numbers for the exponential, then that means that's my range. Because your x and y values switch. If my range is 0 and above, then on the logarithm, that's the domain. Again, inverse means your domain and range switch. So if we look at 15, we've graphed one similar to this. So putting that into Desmos, sketching the graph that you see from Desmos, it should be approaching 1. That's what we would be looking at, that you should see on Desmos. Domain, always all real numbers for this. The range, this time, it's approaching 1 instead. So these are those logarithms we've been writing. So in order to get to solve for y, I need to subtract 1. So that I have x minus 1 equals 3 to the y. Rewriting that as a logarithm means that's going to be log base three of x minus 1. That's what goes into Desmos. That's what your Desmos graph should look like. Again, definitely using Desmos to come up with these. So now all I gotta do is just switch these two. My domain is now approaching 1, and my range is all real numbers. Domain and range switched. That's all we have to deal with. Okay. So 17. This one is another one that approaches 0. Okay, so we have that looking like that. So then the question is, where we know it's log base 4. Look at writing that inverse. Here's the exponential equation. Here, there's nothing added after that base. It's all in the exponent. So at this point, we can rewrite it as a logarithm. All of that is the exponent. So that becomes y plus 2 equals log base 4 of x. Finish solving for y by subtracting 2. So the 2 is subtracted after the x. It's not subtracted with it. And that should give you the graph. And there's your inverse. Domain and range of this one are the same as 13 and 14 because you're approaching 0 on both of them. Okay? So while I pass out the homework, answer one last question for me.